Koji Sato asserts that the company's new electric motors coming this 2025 are in every way superior to those produced by other in-house manufacturers, such as Tesla, NIO, Porsche, and Nissan. Sato claims that this revolutionary electric motor is cheaper, smarter and greener. And in today's episode, we're going to find out what kind of electric motor this is. And so stay tuned. A new design for the motor generator and the remainder of the powertrain's components will be used in Toyota's new line of electric motors starting in 2025. The transmission, the inverter, which has power electronics to manage both alternating and continuous current, and the software that unifies everything together make up the overall system. According to Sato, the set has a format and set of standards that are better than those that any other automaker could create on their own. Toyota has demonstrated its commitment to electromobility by establishing a new internal division that is only focused on electrified transmission lines. This demonstrates Toyota's commitment to the development of electric powertrain componentry. The features being given for 2025 are the outcome of this work, which also decreased the development of internal combustion engines because it is a field of endeavor that will undoubtedly stop being profitable in the upcoming years. According to Toyota, its new engines offer a better energy density compared to the current generation since they are more efficient, compact, and lightweight, as well as more sustainable. They can also be produced more cheaply than electric motors made specifically for one purpose thanks to their scalability. The integrated powertrains made by Toyota are capable of handling many different jobs. In dual-motor electric vehicles, they have a secondary output of 134 horsepower and a primary output of 402 horsepower. Toyota focused on cooling and copper winding design, both of which are novel in comparison to existing systems, to meet these requirements. Permanent magnets, asynchronous, without magnets, commonly referred to as induction motors, and externally excited motors are the three motor technologies on which the company is currently working. In the case of permanent magnet motors, the rotor, the rotating part, maintains the customary properties of this element, with the magnets right on it. The stator cooling water jacket, which houses the copper windings that produce the magnetic field created in the magnets, is where the distinctive feature is situated. The Toyota EcoFluid, a dielectric refrigerant oil, which does not conduct electricity, that comes in direct touch with the windings, is carried within via a few grooves. Because of this system's excellent performance regardless of temperature, the motor can handle a wide range of power characteristics while significantly cutting down on losses. Through more effective operation, this keeps the engine from overheating and increases its lifespan. Furthermore, Toyota claims that its technologies are up to 14% more efficient than current drivetrains. They also have cheaper production costs than a powertrain designed for a single application due to their scalability, which enables savings in complexity, investment, and manufacture. The winding's shape has also changed, departing from the typical hairpin type that gets its name from the way its component wires look like hairpins and are connected by a large number of solder points. There are only 24 solder points on these twisted windings, which were created in a single process. A smaller, 15mm rather than 28mm, winding head is used to create the joints. The engine can run constantly and more rapidly thanks to cooling, reaching 85% of its theoretical maximum power. Likewise, the heavy rare earth elements in this design can be lowered to just 1%, which makes it simpler to enhance cooling. In addition to increasing power and torque density and cutting down on the amount of raw materials consumed, the new winding design shortens the total length of the motor by 10%. Quite different from the norm is the transmission design as well. In both the first stage and the second stage, the engine rotations are reduced. Afterward, power was routed through a unique differential to the wheels. A stack of two planetary gear sets, one inside the other, is now part of the new transmission, which also serves as a differential. The end product is 25% smaller, 10% lighter, and 20% less susceptible to transmission losses than present designs. At the same time, noise cancellation and other improvements are genuinely compatible with current technology. Meanwhile, let's dig deeper into hairpin motors and the technology behind it. Electric vehicles are using more and more hairpin motors. Compared to earlier varieties of electric motors, they are easier to construct, more effective, and have higher power densities and thermal performance. What is a hairpin motor? Electric motors that wind their stator using hairpins rather than spherical wires are known as hairpin motors. In comparison to wires, hairpins are rectangular and big. The copper winding is more efficiently used, about 20% more efficient, due to its rectangular shape, which allows for a superior fill factor. There are numerous advantages to hairpin winding technology. The additional copper produces a stronger magnetic field because the fill factor is better. This permits a stronger rotor rotation and more torque at the wheels. The stator can be smaller with a better fill factor. Copper losses, or the amount of energy lost as an electric current passes through copper, are negligible. This is caused by the optimal winding path, which has winding turns that are all identical and symmetrical in shape. The electric motor can generate the same amount of power while using less energy, which helps increase the vehicle's range. Hairpins are more simple to wind than round wires because of their symmetrical design and solid design, which greatly simplifies installation. Stitch cords are required to hold the wrapping of round wires together, a procedure known as stator lacing. Hairpins don't need to have this. Long-term failure rates for hairpin motors are lower. This is because vibrations have less of an impact on their bigger, stronger conductors. Round wires cannot carry as much current as hairpins. With more efficiency, the winding and the motor produce less heat. The motor's dependability and longevity are increased, and temperature regulation is made simpler. Hairpins can be placed precisely, which makes for a more cleaner look than spherical wires can. The installation of the hairpin technology has significant challenges in ensuring functionality, notably in traction drives. The most difficult procedures in this regard are those involving bending and welding. When bending, strict specifications for damage-free insulation and precise geometry must be met. Up to a non-functioning stator can result from improperly welded hairpin, which ends in electrical losses. Why isn't hairpin technology more popular? Primarily because the production procedure for hairpin winding is extremely complex. Before being automatically put into the stator core slot, the wire must first be bent into a hairpin shape. After that, the ends need to be twisted and joined. So it is impossible to manually produce hairpin motors. Building a highly productive production line for these motors needs a considerable investment. Never underestimate 1%. Comparing a motor with hairpin wiring to one without, this technology improves an electric motor's typical efficiency by more than 1%. The fix is only 1%. Nevertheless, do not undervalue 1% because it offers a number of important advantages. The maximum efficiency zone size is expanded in the first place. This implies that you can drive efficiently at both high and moderate speeds on the highway, even in congested urban areas. More stator windings can also be fitted into the hairpin motor. This indicates that the motor can produce more power and torque with the same energy loss. Likewise, the flat wire utilized in a hairpin motor has a more symmetrical shape, which lowers the thermal resistance in the stator slot. The peak power and sustained performance are further enhanced by the improved heat transfer efficiency it provides. And finally, but not least, the motor itself delivers better stiffness because of the winding's increased stiffness. A smaller slot can be used in the electromagnetic design, which lowers mechanical and electromagnetic noise. Having said that, this is the tale of Toyota's latest generation of electric motors, which was created as a component of the major shift towards a future with more environmentally friendly transportation. It is unclear if they will be able to exceed Tesla and the other companies named at the outset, but in any case, it will be a fantastic benchmarking opportunity for all electric vehicle makers worldwide. Do you think Toyota can outperform Tesla? Let us know in the comment box below. And if you've watched up to this point, thank you so much. For more videos about EVs, Toyota, Tesla, Ford, and the most recent auto news, please consider subscribing to Tech Addicts.